Hello there and welcome to A2 Maths on June 2018, paper 2, and here we're looking at question 9, differentiation from first principles questions. So given that theta is measured in radians, prove from first principles that the derivative of cos theta with respect to theta is equal to minus sine theta. You may assume the formula of cos A plus or minus B, and that as h tends towards 0, sine h over h tends to 1, and cos h minus 1 over h tends towards 0. So what we're then going to do with this is we're going to remind ourselves of that differentiation formula. It's going to be the limit as h tends towards 0 of f of x plus h minus f of x all over h. Okay, so let's get started. In this case, our function is cos, so we're going to be using cos as f of x. So the limit as h tends towards 0 of cos x plus h. Oh, so it's theta, isn't it? So it's theta plus h minus cos of theta all over h. So what we'll do now is we'll expand the bracket of cos theta plus h. So that's going to be cos theta cos h, and then it's going to be minus sine theta sine h minus cos theta all over h. Let's now just reorganize what we've got slightly. We've got two cos thetas, so we can effectively factorize that. So it'd be cos theta and then inside some brackets. The first one is cos h, the second one is just a single cos theta on its own, so it's effectively minus 1, and then it's take away sine theta sine h. Now what we can do is split this up into two separate fractions and say that they're both over h. Now what we'll do is we'll now take limits. Now cos theta, that's like a coefficient as h tends towards 0, but we know that cos h minus 1 over h will just tend towards 0, so this term here will just effectively become 0, and sine of h over h, that will become 1, so the answer to this question is just minus sine theta. So there we are, that's the answer to question 9, 5 marks for that, and I'm hoping that you can do these really quickly, get the 5 marks in the bank and move on to more harder questions pretty quickly. So practice at these, it's probably going to come up in the exam, be ready for them so you can spend more of your time on the harder questions. That's question 9, let's move on to question 10.